use again next year, so please pay careful attention, okay? I'm going to show you how to do this thing called solving quadratic inequalities in one variable, okay? One variable today. In section 9.3, we'll show you how to do it with two variables, okay? Now, I think I've already showed you something like this before when we did chapter 4. So I want to go back to what we did in chapter 4, and hopefully we can do that same question again, and that'll give you an understanding of what to do when you solve quadratic inequalities. Remember back in chapter 4 when we talked about something called the nature of the roots of a quadratic? 2 roots, 1 root, no root. What do we look for? The discriminant, right? We looked at the discriminant. Good. And remember what the values were, or the expression was for the discriminant? B squared minus 4ac, right. Okay, so if b squared minus 4ac was bigger than 0, then how many answers did you have? 2, right. And if b squared minus 4ac was equal to 0, which you had this on your last test, of course that's one real root. And if b squared minus 4ac, which equals to the discriminant, was less than 0, how many roots do you have? No real roots. Okay. Now, in chapter 4, we dealt with a question like the following. It says, find the value of k such that this function, y equals to x squared plus kx plus 4, has two different roots. So when I say two different roots, you need to figure out that this quadratic inequality, which talks about b squared minus 4ac, must be what? Greater than 0. Okay, what's b in this example here? If I look at this function. K, so it's k squared minus 4. A is just the number 1, and c is, in this case, 4. So we want this to be bigger or equal to 0. I will write this a little bit nicer. K squared minus 16 is greater than, not bigger or equal, just greater than 0. Okay? So I think in chapter 4, what I first showed you was this method using your graphing calculator, where you have to graph this corresponding function. So let's do that, okay, just as a review. So for those of you who have your graphing calculator, bring it out. For those of you too lazy to bring it, too bad for you. Okay? So when you want to do something like this with the graphing calculator, you want to put in an equation. And can someone suggest to me what equation I should put in? That's right. So we don't have a k value, but I write down x squared minus 16. So please graph that out, if you may. And then I would suggest you start with the standard window, and hopefully you can make it look nice by finding the correct fit. Sorry, say it again? Oh. So what's wrong with my picture here? Can't see the vertex, so let me go down and change my window. Maybe I'll make that negative 20, and I think that looks better. Yep, that looks good. Okay, so I'd like you to quickly graph this out in the box to the right, and then I'll show you how we can solve it. Okay, so do a quick sketch. Okay. Okay. Maybe you can actually tell me what these points are. Can you suggest to me what the y-intercept and the x-intercepts are? Not there yet. Okay. Say it again. Say it again. What's the y-intercept? Oh, did you get me x? Okay, what was the x then, Gia? What was it? Negative 4 and 4. Thank you. And the y, I believe, is negative 16. Okay. Okay. There's your lovely graph. And now the question is, what does this graph do, or how does this graph help us solve this inequality? Okay. So let's look at this little blurb to the left here. It says, we want to find out where the function is what? What are we looking for in this case again? Bigger than 0. Good. So when I ask you to find something that's bigger than 0, this implies that we want to look at where the graph is above, thank you, the x-axis. Okay. And by the way, if I asked you for less than 0, What do you think we're looking for? Below, right. Okay. So we've graphed the function. We've plotted the zeros, especially the x-intercepts. And now I'm going to ask you, for what values of x, because you're solving for x, is this graph above the x-axis? So in your notes, point to where it's above the x-axis. Yeah, I see people pointing here. And where else? The other side. Good. So how do we describe all those values of x? They're greater than 0. Here's x equal to 0. Remember, 0, 1, 2, 3, 4. So it's not greater than 0. Greater than 4 over here, yes, and less than 4. Bravo. So your solution really lies along this x-axis. It's all of these values that I'm going to put in green. And those values would be x is less than negative 4, or x is greater than positive 4. Good. Okay? That's how you do things visually. Okay? However, when you do your AP exam next year, there will be parts of the test where you're not allowed to calculators, so you better know how to do it algebraically as well. So let me show you how to do it algebraically, and I'll show you actually 2 different ways. And then once again, you have to pick the one you like and make sure you learn it well so you can solve the equations. Okay? So method number 2, this is the algebraic way. Okay? Once again, we're trying to solve the inequality of, and I think it was x squared minus 16. And remember, our inequality was bigger than 0, right? But when you do it by algebra, the first thing I want you to do is find its roots. So what you want to do is make that inequality into a equality. So make it equal to 0. Okay, because I'm trying to find the roots, or the x-intercepts. This one's easy to do. Can someone tell me what the roots are? You should know anyways. Yeah, negative 4 and plus 4. We got that from above. Okay. And then here's where those 2 algebraic methods differ. Okay. So let's do 2a first of all, over here. Okay, this is a line. Let's do 2a. So once you found the roots, this is what I'd like you to do. Okay. I'd like you to plot the roots on a number line. So let's say here's 0. So 4 is over here. Negative 4 is over here. Okay. This is important, so listen up. Okay. Now, once you've done this, I want you to understand that these roots are like boundaries. Okay. So you've actually split up the number line into 3 different regions. This region, and this region over here. Okay. Can you see how there are 3 parts? Right? A whole line, chop it in 2 places, 3 parts. So here's what I'd like you to do. Our goal is to actually figure out which part is, what am I looking for again? Which part is larger than 0? So your question here is, you're asking yourself, which part is bigger than 0? Because that's ultimately what you're trying to solve for, okay? Now, how can I tell which part is actually bigger than 0? Plug it in. Sure, we're going to plug in stuff. So I say choose what I call test points for each interval. So for the interval in yellow, which test point should I choose? Okay, don't choose negative 4 because it's right on the border. Don't choose the number that's right on the border. So choose something to the left of negative 4. Sure. So let's test out negative 5. Okay, so we'll test out negative 5. And when I ask you to test it out, we're putting it back into the original equation of x squared minus 16. So negative 5 squared take away 16. Somebody calculate that for me. 9. Okay, good. So because that number is 9, it's positive, I know that everything in that region must be positive. Okay, so I write down the word POS, pause. Does that make sense? Okay, I've tested one of the points in that region. Okay, it's positive, so I know that whole region is positive. Okay, and then I'm going to ask you to test out another point in the middle region. So what number would you like me to try in this middle region between negative 4 and 4? Really? 2, 1.5? Make life so hard. What's an easier number? Yeah, 0. If you like hard stuff, go right ahead. But judging by your reaction from the test, you don't. So 0 minus 16 is negative 16, and therefore this number is negative, meaning everything in between the values of negative 4 and 4 must be negative. Okay. And last but not least, choose a number that is bigger than 4. 5, sure. And then go ahead and evaluate that again. Same answer as one in yellow, you bet. So that's 9, therefore it's positive. Okay. Now, once you're done on the test point stuff, once you looked at your number line and you wrote down the words positive, negative, positive, what's my final answer going to be now for this question? Remember I asked yourself, I'm looking at where this graph is bigger than 0. Bigger than 0, is that positive or negative? Oh, come on. Yeah, positive, right. So we're looking at the yellow region and the green region. So therefore your solution is the same thing. The yellow region is x is less than 4, and the green region is x is greater than 4. Can you see what you've actually done here is kind of make a little sketch of the graph? Can you look back at your graph and see how this number line represents the graph? Can you see that? Right? What am I saying here? To the left of negative 4. All this stuff to the left of negative 4, the graph is positive. It's above the y-axis. Okay? Between negative 4 and 4, the graph is below the axis, so it's negative. And then bigger than 4, it's back again above the x-axis, so it's positive. So this number line really is a quick representation of the graph. Can you see the connection? Okay? All right, let's do 2b, and then I'll let you decide which algebraic way you like. Okay? Here's method 2b. So you're still doing algebra. The first part's still the same when you want to find the actual roots. Okay? Now, I must admit, when I do 2b, I really shouldn't have solved using this method over here with the green. Okay? So maybe what I'll do is I will actually do this part again. So I'm going to whoop like that. Because in method 2b, I don't want you to isolate x. I want you to factor into the actual factors. Can someone suggest to me what x squared minus 16 factors into? Yeah, x minus 4, x plus 4. Good. Okay, now with this method, we're going to use these factors. Okay? By the way, this of course gives you x equals to 4. This gives you x equals to negative 4. So with method 2b, it's what we call, let's look at the factors and do some sign analysis. And so what I'm going to ask you to do is, you see how there's two number lines written here? You see how I have two factors? I want you to write the two factors beside the two number lines. Okay, so here's x minus 4, and the other factor would be x plus 4. Okay? You're thinking, well, what's the bottom number line going to be? Well, the bottom number line is both of them put together. Okay? Now, with this method, and please pay attention, with this method, what you're doing now is you're looking at the individual components first, and then we'll combine them together. If I were to look at the number line for x minus 4, let's just look up here for now, okay? Where is the 0 for x minus 4? It's at the value of 4. Good. Let me ask you, x minus 4 as a visual, what kind of graph does it look like? Parabola, line, what does it look like? Line. Is the slope here positive sloping or negative sloping? Positive sloping. So if I asked you to tell me what would be the values less than 4, are they going to be positive or negative in terms of the y values, what would you say? And if I asked you what are the y values after 4, what would you say? What? Okay. Here. Let me ask you this. Okay? Think about the equation, y equals to x minus 4. Don't write this down, just watch. Okay? Just watch. How does it look like when you graph it out? Right? And it goes upward, right? So I guess my question to you is, to the left of 4, look at the graph. Is it above or below the y-axis? Below. So I want you to understand this is below. What about afterwards? After 4, it's above. Okay? Now, if you didn't like that, because you're like, I don't know how to graph out that line, I guess what you can do in this step here is you can also test out some points. So you could have also tested a point. Choose a value that's less than 4. What would it be? Let's test out 0. Well, when I plug in 0 into x minus 4, what do I get? Yeah, 0 minus 4, that is just negative. So that's why I have here negative. And if I chose a value that was bigger than 4, let's say 10, and I plug that in, 10 minus 4, that's 6, so that's positive. So you see, once again, what I'm doing is I'm trying to find the different signs, negative, positive. Okay. By the way, do the same thing for the one underneath now. Okay. Plot the 0, negative 4, and then now tell me, where is it negative, where is it positive? So test some points if you need. Okay. To the left of negative 4, can someone tell me what you get? Negative or positive? Negative. Good. To the right of negative 4, what do we get? Negative or positive? Positive. Okay. We're going to combine all this stuff together now. You ready to combine? If I were to combine, how many zeros should I plot on this bottom number line? Negative 4 and 4, right? The two zeros. I'm combining together. Okay? Okay, now be careful here. Just watch. Okay? Watch first, and I'll give you time to write this down. Watch first. You see how there's a region here? You see how there's a region here? And you see how there's a region over here? Perhaps. Can you see the three regions? Just like over here, how we had three regions? Okay, I didn't code it correctly, but let me just code it correctly for you then. This region here, this region. Okay, now let's take a look. What are the final signs for my number line on the bottom? Say that again, Katie? Did I switch these? No, second number. What's the second number? Line. This second line. Shouldn't they be switched, you mean? Yeah. No, because look, it's still positive x. It's an upward sloping line, right? You were thinking if this was negative x, downward sloping line. Yeah. Okay, let's look in the yellow region, okay? First factor, is it negative or positive? Negative. Second factor, negative or positive? Two negatives multiplied together. Positive. Good. Okay. Just watch me first. I'll give you time to write in a second. Okay. Let's look at the region in the middle. Okay. First factor, negative or positive? First factor, negative or positive? Still negative. Second factor, negative or positive? Positive. Negative times a positive gives us a negative. Okay. Last one. Watch me first. I'll give you time to write this down. Positive. Positive. Positive times positive is positive. So look, in this method, you get the same number line as what you did over there. Okay? And therefore, your answer is also the same. Okay. Now write this down, and then I'm going to give you a few seconds to tell me which method you like better. Okay? Number 1 on the next page, what I'd like you to do is go through the same three methods. Graph first, then the two algebra ones, and then hopefully you get the same answer. Okay? Now, for those of you doing graphing, which is all of you, what do you want to do? What equation do you plug into your graphing calculator? My advice is always move things to one side and set the other side equal to 0. So perhaps you want to move all the terms to the left side. And so therefore you have this equation you're going to put into your graphing calculator. And because this one is less than or equal to 0, what am I looking for? Where the graph is above or below the x-axis? Good. So since you want this to be less than or equal to 0, look for where graph is below the the x-axis. Okay? So I think that's good enough as a hint. It's your turn to do the rest. Go. I'm too lazy. Negative 1 and what? 2 and 2/3? Yeah. Oh, 8 over 3. Right. Okay. That's good. Yes, it is. I just have too much earwax in my ears. I don't know. I don't know. Maybe it is. Okay, so what's my solution here then going to be? Yeah, I want the part that's between them now. So negative 1 and then 8 over 3. And now be careful because this one says less than or equal to 0. So what should I do with my signs? Better put the equal sign there as well. Okay, so don't make that tiny little mistake. Okay, all right. Yeah, because my original question had the equal sign there with the inequality. So that's why in my solution I should also put the equal sign. Okay? All right, ladies and gentlemen, you know the answers now, so go ahead and solve for the algebraic methods. And once again, for those of you who forgot what to do there, I want you to solve the related equation to this inequality. What is the related equation to this inequality? That's 3x squared minus 5x minus 8 equal to 0. By the way, if you have to solve this without your graphing calculator and all that, what should you do? Plug that in? Can't plug it in. So, up to you. I guess you could plug it in, factor or use the quadratic formula. It's up to you. Okay. Do you know why factoring is so important then? Kind of, because you see it again and again and again. Find two numbers that multiply to negative 24, add to negative 5. Help. Negative 8 and positive 3, Bronte says, like it's so hard for her to say. Okay, so x minus 8, x plus 3. Don't forget, using choose method, what do we need to do as an extra little bit? Divide everything by 3. Oh, yeah. Then simplify. So I'll bring the 3 up. 3x minus 8, x plus 1. Oh, yeah, that's great. Because then you get your answers of 8 over 3. And like what Edison said, that's 2 and 2/3. Or negative 1, which is x equal to negative 1. Okay. Of course it's the same answer, because it's the same question, but you're just doing it a different way. If it's not the same answer, we're in big trouble, aren't we? Okay, so ladies and gentlemen, you try the rest, see if you can plot the numbers on number line or make the sketch, figure it out. Okay, and then after that, we'll go on to some more interesting things. Okay, ladies and gentlemen, I put my answer on the board here. If you can double check yours with mine. Now, just to let you know, when I did the test points, I just chose random numbers, okay? But I had to choose random numbers in the right region. So, for example, for this region here, I chose to use negative 2. For this region in between, I chose to use 0. And for this far region over here, I chose to use 3. Now notice what I also did. I was really lazy. You see, I didn't even get the final answer. But all I knew was that it was going to be negative because I can see like the progression of the numbers. So, you know what? When you're doing this, if you get a number, that's great. But if you can't, or if you feel like, oh, I know how to do this already, that's fine. By the way, I think I messed up here. This should be all the opposite, right? Yeah. So, bottom line, don't be lazy. Go ahead and evaluate. Okay. Hey, I make mistakes just like you. I'm human. Sometimes I make them on purpose, sometimes I don't. You have to decide when it's on purpose and when it's not. Okay? So, your answer, of course, is the same as what you had above, and it's the same on both cases. Remember, for this one, you're looking at where it's negative, right? You want to find out where it is less than or equal to 0. That means it's negative. So, of course, I'm looking for the region in between. Okay? There you go. How are we feeling about this? This concept's pretty tricky, but are you okay? Not bad? Now, once again, with the algebra part, if you don't like method 2b, then don't use it from now on. Okay? Anna, that's for you. Okay? All right. So let's do example number 2 on page 3, and that might be the last one I do today. And I'll come back next day to do examples 3 and 4 and beyond. Okay? Bless you. Can you just graph all of them? Yes, you could, but you're also going to know how to use the algebra way as well. Okay? Okay, ladies and gentlemen, here's another question, and you've seen stuff like this before. Okay? We've done the ball throwing stuff before. So here we go with throwing a ball. Initial speed, it goes like this, right? Richard, please. Victor, Tony, okay? We've got this equation, and I'm asking you to set up an inequality to find the time interval the ball is above 10 meters. So I guess I'm asking you, where is this ball above 10 meters? Okay? How can I write any inequality for this? I have the inequality which talks about the height. Now, what does the height have to be? Bigger or equal to 10 meters? Bigger? Above means bigger. Good. Okay, ladies and gentlemen, there's your equation.
Wait.
That's A. That's part A. Yes, Edison. Question?
Why is the guy like floating? Is it because it's a height of 2.1 meters?
No. Yeah, he's standing on a platform, 2.1 meters. He is. Yeah.
Is he really, or are you just like?
Yeah. Read the question. A ball is thrown with an initial speed of 18 meters per second from a height of 2.1 meters above the ground.
What if it is 2.1 meters tall?
What if he's 2.1 meters tall? Okay, then he's a really.
Oh, sorry.
He erased the whole thing. What if he's 2.1 meters tall? Okay, fine. Those are his arms, and here are his legs. There you go. Okay? Diagram not drawn to scale. Okay. Ladies and gentlemen, yeah, that's Yao Ming right there. 7 feet. How are you going to solve this using one of the algebraic ways? Okay, let's focus again, please. Don't have much time left. How are we going to solve this? What do I always tell you to do when you solve? Do stuff, yeah, but maybe you should move everything to one side because you know what? Having things that are not equal to 0 on the right-hand side make life hard. 10 minus 2.1, that's minus 7.9. Okay. So when you get to this, please, please, please do not try to factor. Let's go ahead and do the following, okay? By algebra, remember what we do by algebra? We want to solve the corresponding equality. So let's do this first, please. Okay, solve for t. And then, of course, in this case, use the quadratic formula. t equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Go ahead and solve for t, please.
Couldn't we just find like the zeros?
Yeah, that's what you're doing. Find the zeros.
No, like calculating.
True, but I said solve it using one of the algebraic ways.
Oh, you can check your answers for solving.
Yeah.
Oh.
Okay, so go ahead and punch that in your calculator. You should get 2 decimals. Give me how about 2 decimal places? Okay. Let's see. I predict one is like less than 1, and the other one is, I don't know, bigger than 1. Don't have the answer yet? No. .51, Helena says. Do I have confirmation on that as the first answer? Hello? Anyone out there confirm that? I don't know if I can trust Helena if I don't have confirmation. You can trust her? Okay.
No.
And what about the other one then? What's the other answer? 3.16? Trust her, yes or no? Why not? It's Helena? Wow. Unwavering trust. Dangerous. Okay, ladies and gentlemen. Now, if we were to continue with this, and I asked you to do this algebraically, you would have to now plot your number line. Uh-oh. And test points. Okay? Okay, ladies and gentlemen, because of time, here we go. Let's test some points. I'll tell you, this is negative, this is positive, this is negative. Okay? Ladies and gentlemen, shh, it is important. Do you know why I know so fast? Do you know why I know so fast? Because I'm great? No. Watch. Look at your equation. Is the a value positive or negative in the equation? Negative. So what does the graph look like? Opens downward. So everything to the left is negative, middle is positive, negative.
So you can just do that?
You can just do that too if you want.